Geometry, Unit 11, Section 1, Distance. Determine the distance between points A, which is negative 2, 3, and point B, which is 4, 6, using the Pythagorean theorem. So, to figure out the distance of a line segment on a coordinate plane using the Pythagorean theorem, what we can do is, Pythagorean theorem, at this point you know well, comes from right triangles. This is just a line. It's not a triangle, but we can make it a right triangle. We can make it the hypotenuse of a right triangle. And what we could do is we could extend a line this way and extend a line this way to draw two perpendicular lines. I know horizontal and vertical lines are perpendicular to each other, and so that will create a right triangle for me here. And then to do Pythagorean theorem, I can't count boxes on a sloped line like AB or something like this, but I can count boxes on horizontal lines and vertical lines. I see this is 1, 2, 3, and this is 1, 2, 3, 4, 5, 6. So then to get this distance here, we could do just simply Pythagorean theorem, as I said, 3 squared plus 6 squared equals, I'm going to use capital D for the distance of AB here, since we're talking about distance right now. And so 3 squared is 9 plus 36 equals D squared. And then how do we solve for D? We do the square root of the sum. So let me add it together first. So 36 plus 9 is 45. So 45 equals D squared. And so the square root of 45 excuse me, equals D. And then we could do this in simplest radical form. Simplest radical form, square root of 44, that's 9 times 5, so 3 rad 5 equals D, and that's what we get here, 3 rad 5. So you can find the distance between 2 points by using the Pythagorean theorem, by creating a right triangle there. Okay, now, sorry, that's not down there, it's next slide. Determine the distance between points C and D using the Pythagorean theorem, but this time I'm not giving you any numbers. I want to do what we did in the previous example, but without numbers, just x1, y1 for the first coordinate, x2, y2 for second coordinate. And first thing we have to do is if this was just x and y, like let's say this was x1, y1, and this was x2, y2. And I wanted to do Pythagorean theorem here. How did I get this was 6? We counted boxes, but there was another way. Is that again, these are your x1, y1s, x1, y1, x2, y2. Where did this 6 come from? Well, the 6 is parallel to the x-axis, right? It's a change in the x-axis from these 2 points. See that the x value of A is negative 2 and the x value of B is 4. What is the distance between negative 2 and 4? So negative 2 and 4. The distance is 6. The distance on the number line between negative 2 and 4 is 6. And the way to get 6 from negative 2 and 4 is not addition. Negative 2 plus 4 is 2, right? How do I get 6? I can get 6 by doing subtraction. If I do 4 minus negative 2, that's how I can get 6. So 4 minus negative 2. If I subtract the second x value from the first x value, I get the distance between, the change in x values. And so we could have done that here too. This could have been 4 minus negative 2. 4 minus negative 2, and that is the 6 that we got for the change in the x values. And where did the 3 come from? The 3 came from the change in the y values. This first point A has a y value of 3, and then the second one has a y value of 6. Again, you see the y value coordinates went from 3 to 6. That's a change of 3. And I can do 6 minus 3. I could do, the second one minus the first one. 6 minus 3, that's where this 3 came from. So the way to do Pythagorean theorem on 2 points, especially if you don't have a graph, is first the way we do like a squared plus b squared equals c squared, the a squared plus b squared here, the 3 squared plus 6 squared came from the change in the x values, and the change in the y values. And the way we could do that change is by subtracting. So if I subtract the x values, and that would be x2 minus x1, that's going to be the change in the x values. Change in x. And then we could do the y values, y2 minus y1. This is the change in y. And that gave us the 3 and 6. But what do we do then? Then we squared that. We squared them and added them together, right? That we did. We had the 3 and the 6, but we squared them and added them because that's what the Pythagorean theorem was. The change in the x and the change in the y, that got us the lengths of the legs. So we squared them, and we set that equal to the distance. Let me write a better d than that. The distance squared. And then what happened after that? After we simplified it down, we did the square root of both sides. So I could simplify this another way. I could put the whole thing, I could square root it, and have it just equal to d instead of d squared. And so the square root of x2 minus x1 squared plus y2 minus y1 squared equals d. This is called the distance formula. And that's really what you're going to memorize, and that's really the big thing from today. But I wanted to take time to point out that this formula does come from the Pythagorean theorem, that the distance formula is Pythagorean theorem. It's finding the distance in the x values and finding the distance in the y values. That's what this is in here. But then we square them and add them up and square root, because that's how you find the length of the hypotenuse in the Pythagorean theorem. So like this next question, this is really what we're talking about here. Find the distance between these 2 points. No picture, no graph. Could I draw a picture and make it a right triangle and do Pythagorean theorem? Absolutely, you could. But we want to use the distance formula, because that's what we need to practice. That's really, we're going to be using this distance formula a lot. See, this unit 11 is coming after unit 10, of course, and unit 10 was three-dimensional geometry. And units 1 through 9 were about congruence and similarity. Those were the modules. And then unit 10 was its own module on three-dimensional volume and area and stuff like that. Units 11 and 12 are what we call the coordinate module. They are all about coordinate stuff, and a lot of it comes from 3 major formulas: the distance formula, the slope formula, and the midpoint formula, and a couple other formulas from those. But the distance formula is probably the most complex of those, and so you need to take some time to memorize it. And that's just capital D equals a giant square root, and we subtract the x values, square them, plus subtract the y values, and square them. And you really don't need to worry too much about which one's the second one and which one's the first one. It works both ways, because if I do 3 minus -2, that's 5. And if I do -2 minus 3, that's -5. But I'm going to square it either way, and it's going to end up being 25. So don't worry too much about which is first and second. But typically we'd say this is the second and this is the first, and so, you know, traditionally I would do -2 minus 3. But like I said, it really doesn't matter for distance. There are some formulas where the order does matter, but for distance it doesn't. So the distance here is, and again, it's coming from the Pythagorean theorem, that if I do -2 minus 3 squared plus -4 minus -1, sorry, lost where I was for a second there, squared. And again, this is giving me the change in the x value. You know, from 3 to -2, they are 5 apart on the number line. It subtracts to -5, but when I square it, it's going to give me 25. And the change in the y values, you know, -1 to -4, they have a distance of 3. Now, when we subtract the negative algebraically, that becomes a plus, and -4 plus 1 is -3 squared. Again, it doesn't matter that it's negative because it squares to +9 either way. And then 25 plus 9 is 34, but remember this whole thing's under a square root. So the answer here is the square root of 34. And that's it. Sometimes this can be reduced, sometimes it can't. Sometimes it's a square number like 16, and the answer then is just 4. So this can change, but that's really it. It's just getting used to this formula, and it's just subtract the x value, square them, subtract the y value, square them, add them up, square root that whole thing. And, where students make mistakes are in the silly things like, -4 minus 1. That's not what we're doing here. We're doing -4 minus -1. And so that's why it became a plus. You have to remember that you're subtracting the second number. And if you subtract the negative, that's when we have the, keep change to plus. But you could always just kind of think, what's the distance between 3 and -2 on the number line? 5 squares to 25. What's the distance between -1 and -4? 3 squares to 9. Doesn't matter that they're negative at this stage because they square to positive either way. And then add them up, square roots. That's your distance formula, and it comes from the Pythagorean theorem. But we're going to see this formula a tremendous amount, not given to you on a reference sheet, a formula you really do need to take the time to memorize because you're going to be using it a lot, and it certainly will be on your next test and, of course, the regions. See ya.